Alright, we got this one hooked up by itself. So, this battery here is absolutely amazing. What I found is the window air conditioner, 5000 BTU, probably draws like 5 amps. Um, you set it for like, I don't know, 65, 70 degrees, and maybe like 10 o'clock at night. This will run that air conditioner all the way until the morning time when the solar starts reproducing again. And usually without any interruptions. And so if you just set the thermostat on the air conditioner perfect, you'll be able to get a good balance. But normally what we were doing before was I was charging this thing. I was literally hauling it inside the house using this inverter. This is a really, really super cheap inverter. It works. It doesn't do nearly what the MPP solar does. I need to clear all this junk out here. This one here is really good, and I don't know if they still sell these anymore. Where I got it from doesn't sell it anymore. And what you really wanted to do with these is buy 2 of them, and then there's a parallel board here, and then you wire them up and you get 240 volts, and then you need a transfer switch and all this other stuff. So this is like really, really good for like the off-grid type of person who doesn't have a huge power demand, because these are only 2.4K. So at the price of when they were $700, they were, still not quite. I mean, it would kind of depend on how you wanted to do it, because they made a 6.5K for around the same price, all in one unit. So the difference was, like, you could take 2 of these and have a little redundancy. So if one of them failed, you wouldn't be replacing the entire thing. But no, there's a pretty big difference between 4.8 and 6.5. I mean, it's quite a bit. So I'm not 100% sure if I remember what the charge controller in here is. I mean, I just can't remember anything anymore for the most part. I feel like I'm not even that old, but I want to say that it's 80 or 120. I think it's probably 80, but I might be wrong. This one here is like 40, and it's really not good to be using for a primary source. So what I'm doing with this one right now is I'm just charging this battery, and later on today I will run this thing when it's dark out, see what I can run off of it out here. But right now we're using these worthless Walmart batteries. There is a different battery. It's not a Walmart battery, but it's almost identical. It came from my old work. So these here, the way that they act is they seem to have no real discharge capacity. So basically I'm just using them as a capacitor. So they sit here. If the solar dips out for too long, the inverter shuts down, because these batteries cannot handle the load for very long. And compared to this, could handle it for hours. Physically speaking, they're equal in size that they occupy. You would think it would be at least half of that. It's not even half. It's not even a quarter. It's just not good at all. But if you're just getting started and doing some kind of off-grid solar thing, then these can work. They definitely can work. But it's like spending money to learn something. So right now I have 470 watts going into this, which is a group of panels of like, I think 10, and then down here I'm using these ones. if we can focus on it. So we got 9 amps, and you'll see that that equals 18 because that's MPPT in action. So the voltage is high, and the amps get converted as the voltage gets dropped down. This one is 27. We have 9 amps. We're probably seeing like 4 come in. Let's see what it is. 5.7 amps, and you can see, identify it because it says PV. That's the battery voltage, and that's the amperage. Why is this thing does not want to focus? Okay. So I'm running 47 volts, and those are, you know, 237 volt panels. And they can vary quite a bit. See, this one's 55. So, these generally, I don't see more than 20 amps on them. Like right now, that one's at 18. It's in a prime location where all the there's 6 panels hooked to this. These are capable of 40 amps. They'll get toasty if you run 40 through them. That's what these fans are going to be for. I will put 2 fans behind each one of these and then run them off the load here and run them in series so they're 24 volts. Or you could put one fan on one and one on another, you know, however you want to do it. But it's a good idea that if you're going to be anywhere near that 40 amp limit, that you do have a fan on the back because they do get hot. So usually also there's let me see here, there's a temperature gauge right here. This is a temperature sensor. You can remotely remove that. The idea was that that was supposed to be on the battery. So we can see right now there's 77 Fahrenheit on that one, and .73 on that. And these will, you know, greatly determine based on ambient temperature too. So obviously if it's 90 degrees in here, they're probably going to be 90 degrees. So, but it's a good idea to have fans on these. These are the best charge controllers I've found for the cost versus the quality. There are cheaper ones out there. There are better ones out there. There are cheaper ones that cost more. So, you know, I like these. I wish they had a little bit of higher input voltage. I would like to have more than, I'd like to change my whole setup to where I have more than 2 panels in series. I want higher voltage, lower current. It's just safer. It's easier. It's easier on the wires. You don't need to go up in higher gauge. You know, I've had connectors melt from too many panels being branched into branches. So I've got breakers on everything. They're not necessarily sized correctly, but something's better than nothing. These are 32 amp breakers. So basically, as soon as this thing gets anywhere near its 40 amp, it's going to trip. So I like having a 32 on it. I don't want these things to be doing 40 amps. That's too much. And I've got a redundant system with multiple charge controllers, so we don't want one of these to support the entire load. And the way you make these things last is you don't use them at their full rated potential. So we got those ones going here, and this air conditioner out here in the shop is like 6,500 BTU or something like that, and I think that it draws like 6 or 7 amps. So I'll see this thing pulling like 700 watts, and then the other one in the bedroom is 5 or 6 amps, maybe 4 amps. I don't know. It's not real big. So between the two of them, you're usually your load is going to be like 1.1K. Let's see here. We've made 2.65 kilowatt hours today. So what that means is that you're not making 2.65 right now. They're calculating it like over the time period that it's been on. And it's really hard to explain that to people, like what kilowatt hours it is versus kilowatts. So like right now, my load, my instantaneous load is 1.13 kilowatts. Okay? You know, if I draw that for 2 hours, I would actually be at 2.26 kilowatt hours. Even though what I'm really drawing is 1.13. But as each hour goes on, that number multiplies. So if you were to put out 1 kilowatt per hour for 8 hours, you would be making 8 kilowatt hours in 1 day. Now, if you put out 2 for 8 hours, it would be 16. So, you know, people get that number confused quite often. So basically, my output right now out of this particular one is about 500 watts. I don't have a way to have this one calculate those down there. So basically what I keep track of on this is whatever goes through here. And this particular one, the up and down buttons are backwards, which annoys the hell out of me. I don't know if that's some kind of Chinese thing. So we're running for a couple of hours and I'm at 2.6, which means they're probably putting out 1,000 watts an hour. We have made 47 kilowatt hours this month. This year, 261 kilowatt hours. For the total lifetime of this, it has made 1.4 megawatts. So I like this particular unit. I've done videos on it. If you guys are interested, you can look at the videos. I've been running it for a couple years now. I think since 2021, 2022, I don't know. And it has some quirks that I don't like, but it works. What it'll do is if it's under load a little bit too much, it'll actually kick the charge controller out and just makes things even worse, because what happens is, so you have a heavy load on this that the solar might be able to handle, but for some reason a sudden load will cause it to disconnect, and then now you have no more solar applied to the load. You're on the battery completely. The batteries are crap. The battery voltage quickly plummets. Now the charge controller disconnects the inverter to protect it. Now the solar charge controller reconnects. The voltage goes back up. The inverter comes back on, and it repeats this cycle over and over and over and over. It's absolutely retarded. So you can adjust the voltages to try and kind of work around that. But the biggest issue with this stupid thing is that, let's say I'm capable of making 1,000 watts right now, and I hook up something with 700 watt load. It's going to kick out that thing. And then, you know, unless your battery can carry you through the event, you know, then you're going to shut down and go into a cycle. So that's what I don't like about this one, and it's really annoying. I believe this one does the same kind of crap too. So if you have a charge controller like this, and it's not controlled by the rest of the crap, this charge controller is never going to kick itself out unless you disconnect the power to it. It will continue to do its job no matter what, unlike this. So there are disadvantages of all-in-one systems. I personally prefer a component system. I would prefer to have a 40 amp charge controller on every 4 panels that I have. And, you know, so I have 40 panels. I would need 10 of these damn things, you know, to do it realistically. You could probably put, for every 8 panels, you probably could put one. But the biggest cost involved in doing any of this crap on any kind of serious scale is going to be the batteries. These batteries, this battery right here, I just put this here. My wife just brought this in. Anyway, another 40 feet of wire. These batteries are over $500. I don't think you'll ever find them under $400, $500. And we're talking 24 volt. We're not talking 12 volt. And One of the things that I've learned in the last couple of years of playing with solar, the higher the voltage, the better. You don't want a 12-volt system. The only reason you should ever run a 12-volt system is for an RV. Because what happens is that lower voltage requires you to have higher amperage. The higher the voltage, the lower the amperage requirement is. So what happens to a 12-volt system versus a 24-volt system is literally your wires are twice as thick to carry the same amount of power, because you're carrying more current and less voltage. It's all about Ohm's law. Anyway, you go to, you know, what they do on commercial off-grid stuff, they're running 500 volts. You know, they're running string inverters. They're running stuff that has very little current and high voltage. And then the big thing now is they don't even do that. There's a micro inverter on every single panel. They're all grouped together. They're all running on Romex. They're using this kind of crap. They're using like 12 gauge, 14 gauge Romex, and they go into the rest of the panel. I mean, each panel is producing 240 volts, you know, all by itself. So that's the way it's done nowadays. And I think that's probably a good idea, because then each panel has redundancy protection. There's an inverter on each panel. If one of your panels goes out, big deal. You're just in parallel with the rest of them. So, anyway, the batteries are just like absolutely ridiculous. You know, if you wanted to run your whole house, you'd need like, you know, 4 of these batteries probably, in my opinion. I mean, you'd probably run off less. And, you know, it depends on what you're going to run. I mean, obviously there's certain things we're not going to be able to run. You're not going to be able to run a 240 volt dryer. You're not going to be able to run 240 volt cooktop. You can, but you're going to have to do a lot of other stuff. But if you find alternative ways to avoid using those type of products, then you could easily run your house off of something less. Anyway, right now I'm trying to get my stuff moved around. I've got more wire. I need to take a couple of panels off of a group of panels and give them their own run. And then I'm going to have this system all by itself, because I don't want them combined lead acid batteries with lithium iron phosphate batteries. So just let this do its thing. Let these batteries run their course. And when they finally become absolutely no good, I'll replace them with another one of those. And none of this stuff is permanent. This is all experimental. The panels are ground mounted. You know, nothing's permanent. You know, it's just simple stuff. So anyway, thanks for watching, guys.